Welcome to the third day of I.O. It's great to be here talking to you this morning. My name is Psiaki, and I'm a software engineer on the AR and VR team. Today, Tom and I are going to talk to you about the tools that we've built to make AR development easy and fast for every Android developer. So as you heard at the developer keynote, ARCore is Google's platform for building augmented reality experiences. You've been hearing a lot about ARCore the last couple of days, and I hope you guys are excited about building for AR. I certainly am. Our goal is that at the end of this session, every single one of you would feel like you can build an AR app. So what we're going to cover today is how you can get an asset, how you can build an app using that asset, and finally, how you can iterate and launch. But before I get into the details, I want to tell you a little bit about something that I like to do. So I really like to time myself doing ordinary things. I'll time myself doing things like ironing a shirt, or even taking a shower, or reading my kids a book. It's kind of quirky, I know, but I like to optimize my time and do these things as fast as possible. Sometimes my kids don't appreciate it that much. So what I want to do today is I want to do something in AR as fast as I possibly can by doing something that I call AR done fast. That's right. I'm going to do a speed run through building an AR app. And Tom, I'm wondering if you can help time this speed run and see just how fast I can build an app in AR. Now, to make this happen as fast as possible, I'm going to use the Sceneform SDK, which is our new 3D framework that we just announced and launched. This framework makes AR development easy in Java. So that I can sort of narrate what's going on, I did a one-take video recording of developing an AR app last night, and we'll see how I did. Let's jump to the next slide. And Tom, are you ready?
Ready.
We'll see. All right, so let's go. Start. All right, so I'm getting my asset from poly.google.com. To make this as illuminating as possible, I'm going to search for a lamppost. We'll see what I find. OK, so this first lamppost from Naomi Chen looks pretty good. Let's have a closer look and see if I like that. This is pretty much exactly what I'm looking for. So I'm going to download the model file. And as you can see here, I've got it downloaded, and I've got all the files here in my downloads folder. Now what I'm going to do is I'm going to open the Hello Sceneform sample app, and I'm going to see if I can get this lamppost being used instead of Andy. So what I'm going to do is I'm going to drag all of the model files into my sample data folder, and then using our just released Sceneform Tools Android Studio plugin, I'm going to import that asset into my project. As you can see, as soon as I click Finish, we've got a Gradle build going that's doing the import of our asset into our project, and we're going to see it pop up in the viewer in just a second to see if we like what we got. There it is. So that's looking pretty much exactly like it did on Poly. And so let's see if we can get that added in place of Andy. So we're going to jump into the code here. And as you can see, Andy is loaded using a resource ID. Now, you might have noticed I actually put this file into the assets folder. So I'm going to change a little bit how I load it. I'm going to load the file from the assets folder. I'm going to drop that in. And I'm loading the file now. And I press play, almost play. OK, done. All right, hang on with the time. Let's see what this looks like. Back to the slides. So let's, there we go. OK, so here's our app. So we're done. We have an app that's running in AR. We've got a lamppost. We can place our lamppost. We can place a lot of lampposts in our office and make our office, you know, as decorated with lampposts as we would like it to be. It's looking great. And so that was our speed run. And so let's see, Tom, how did I do there?
1 minute, 45 seconds.
1 minute, 45 seconds. That's minutes, not hours. OK, so that's how fast we can build with AR. But now we're going to slow down. And we're going to talk through all the tools that we've built that make this possible. So the first thing I'm going to do is talk to you about assets. You can get your assets that you'd use in an AR app from many different places. You can source them online. You could have an artist create custom assets for you. But what I'm going to do for this talk is we're going to get our asset from Poly. Now, Poly is Google's library for 3D assets. On Poly, you'll find thousands of 3D assets that you can use in your apps. As you saw, I was able to easily search for a lamppost and find exactly what I was looking for. But if you want something else, like a tree, you can search for that, and there are lots of trees available in all sorts of colors, shapes, sizes. There are maybe some dangerous-looking ones. Whatever you want, you'll find what you're looking for. But if you don't know exactly what you want and you just like to be inspired, you can browse by category. Maybe you'll find an asset there that will inspire you to create a whole new AR app. So have a look around and see if you can find something that you like, and I think you will. Most of these assets, or many of these assets, are licensed under the CC BY license, and so that means that you can download model files for these and use them directly in your apps. All you have to do is credit the author, and then you can use them. So here I'm downloading the model file, and look at this. I have an asset. As you saw in the speed run, here it is. Now, if you look closely, you'll see that this asset has 3 different files. Now, you want to make sure that you keep all of these files together, because each one of these files is important to actually be able to render this asset the way we want to. But what do we do with these files now that we have them? Just for fun, let's crack one of them open in Android Studio and see what it looks like. So this doesn't really look that much like a lamppost. Maybe a little bit, but you probably were guessing that this wasn't going to look like a lamppost if we just opened up the raw files. As you can see, we've got an image, we've got some text, which is showing what all the vertices are in this object. You might love a file like this if you're a graphics developer, but and if you were using a game engine like Unity, it would know exactly what to do with this. It'd be able to render this. You'd be able to tweak it. It'd be great. And I actually want to stop for a second and let you know that at 11:30, right here on stage 7, or of course streaming on YouTube, there's another session called Building an AR App with a Poly Toolkit for Unity. And you can learn a lot more about Poly and more about using these assets in Unity. But for now, because we're not building a Unity app, we're going to build a native Java app. We want to see how we can use these assets in Android Studio. So let me talk to you about Sceneform. So we can work with 3D models in Android Studio using Sceneform, or using the Sceneform Tools plugin that we just announced and is available now. We announced it at the developer keynote on Tuesday. So Sceneform is our high-level 3D framework, and it makes building AR apps in Java easy. Now, Sceneform includes a runtime API, and that handles all of your rendering. It handles doing things with ARCore and making your app work on the Android side. But Sceneform also has a set of tools that interact with Android Studio and let you import, view, and tweak your assets right in your IDE. So where do you get this plugin? Well, like most other Android Studio plugins, you can get your plugin right from the Android Studio plugins page. You go to Preferences, Plugins, Browse for Plugins, and just search for Sceneform, and you'll find it. So once we have the plugin, it's super easy to get your assets imported. The first thing we need to do is place our source files in our project. We're going to drop them in the sample data folder. Now, this is a little bit important because the sample data folder is a folder that does not get bundled into your APK. Now, you might wonder, why would I want these files not bundled into my APK? Well, as you can see here, well, actually, hang on. I missed one thing. As you can see here, we support OBJ, FBX, and GLTF files. And so we're going to focus more on OBJ files right now because that's what I got from Poly. But this exact same flow works with FBX and GLTF, which you might find other places online or source from artists, things like that. But anyway, so we drop these files into our sample data folder, like I said, because we don't want them bundled into our app. Why don't we want them bundled into our app? It's because we build runtime optimized binaries that Sceneform will be able to use to render your assets in Android. Now these binaries are optimized so they load fast and they look great. They include all of the data that you need in order to render, or in order for Sceneform to render your models. So that file, actually, can you go back one slide? So that is the SFB file. And so you're going to hear a little bit more about SFB files later, but just suffice it to say that SFB files are the files that we want bundled into our APK. OK, so now that we have our file, or our set of files in our sample data folder, we're going to right-click, and using the Sceneform Tools plugin, we'll click Import Sceneform Asset. This will trigger our import wizard flow. So this is the import wizard. As you can see, this is fairly simple. We have 3 fields to fill out. The first is the file path to our model, and that's already filled out for us. The second 2 are outputs, and both of these files are created by the import wizard. The first file you'll see is an SFA file, and I'm going to go into that in detail in just a couple of minutes. But this, for now, you just need to know this should be placed right next to your model, because this is going to become one of the source files that will show how your model is rendered. Your SFB file is what you want bundled into your APK. And so you're going to want to put that somewhere that gets bundled. You kind of have 2 options here. Your options are your assets folder and your res-raw folder. You can put it in either of these. The loading is slightly different when you get to the runtime. But other than that, they'll both get bundled, and it doesn't matter. You can pick whichever one you choose. So that's all we have to do in the import wizard. We click Finish, and we're done. Let's see what happens next. So as you can see, as soon as we click Finish, we're going to have a Gradle build kicking off. We're compiling here the SFB that we just imported. Now what's going to happen is we'll get these Gradle tasks added. We're picking these defaults that we're going to fill in the SFA that I'm going to tell you about in a second. And we're building this runtime optimized binary. But as soon as we finish this build, as soon as we finish this build, we're going to see these SFA, SFB files added to our project. And so you can see we've got our SFA next to our model and our SFB right here. I think I have it in res-raw right here. But that's not all. We also have a viewer. And so the viewer is going to pop open as soon as you get your asset fully imported. And as you can see, we see exactly what our model is going to look like here. Here it looks just like it did on Poly, which makes sense because that's what we implemented, or that's what we imported. And you don't have to deploy to your phone. You can just see it right away. You don't even have to have an app built yet. You could just import it right into your project and view files without having your app built. And this uses the exact same renderer as our runtime. And so what you see is what you get. This is going to look just the same on your phone. OK, so this looks just like it did in Poly. But I was thinking I wanted it maybe a little bit different for my app. In Poly, it sort of looks maybe like it's kind of rough, plastic maybe. And I was hoping it would look maybe a little bit shinier. So let's see how we could do that. So I talked to you about the SFA a couple of times. So there was a text file that you saw in the viewer. And so that file is your SFA file. The SFA file defines how Sceneform will render your asset. You can see it has a bunch of different parameters. And if you look closely, you'll see that these might affect the way your asset is going to look. So we're going to look at a couple of these. One of them here is metallic, and one of them is roughness. And so by default, when we import from Poly, we get something where the roughness is 1 and the metallic is 0. And that's going to make it look like it's sort of made out of plastic. And what I'd like to do is turn the metallic up, maybe to 1, so it looks really metallic, and turn the roughness down. Maybe not all the way to 0. I don't want it too shiny, but I'm going to turn it down, and then I'll see what happens. So as soon as I save the SFA file, we're going to rebuild the runtime bundle, and as soon as that is complete, we're going to see that reflected in the viewer. So here you can see, I guess this GIF is sort of looping a little bit, but you can see once it completes, the viewer is looking a little bit different. It's looking pretty metallic, and this is basically what I'm going for. So I want to point you to this documentation online. So I mentioned a couple of the parameters, and there are actually a lot more parameters that you can edit in your SFA file. There are a lot of parameters that affect the look and feel of your asset, but there are also parameters that affect things like its scale or the way its collision works for when you're tapping on your object. And if you check out this page, you'll see all of the details on all of those parameters. Now, one thing I'll mention, I mentioned how we support GLTF, FBX, and OBJ files. When you import each of these files, the parameters will be slightly different that you can edit in your SFA. And all of the details are on this site, so I would strongly recommend you go see which things you can tweak in each of these types of files. OK, so we've got our asset looking the way we want it to. Let's see what we need to do to get it in AR. Now, you remember I talked about placing the runtime optimized binary, the SFB, in the assets or res-raw folder. So let's look at how we would load that in our runtime out of each of these. So as you can see here, this is an activity that you guys are all very familiar with. We have an onCreate method, and what we want to do is our model renderable is an object that in the runtime is going to describe all the details of how to render our lamppost. You could think of this as the runtime representation of our file that has our optimized model. And so what we need to do is we need to load our file into the runtime here, and we're using that using the model renderable builder. Now, loading can take a little time, so this API is an asynchronous API, and all we have to do is create a builder, set its source. Here I'm setting it to a res-raw, or a resource ID in res-raw that points to the lamppost, and build. Now, the model renderable builder returns a completable future. And so that completable future, we're using this then accept method so that after that's complete, we can go and store the renderable that's loaded into our lamppost renderable so that it can be used later. So this was for loading out of res-raw. If we were to load out of assets, it's just slightly different. This code is almost exactly the same, except for one line. When we set the source ID, we just need to set it to a URI and parse out the actual file name instead of a resource ID. You'll notice this is just the lamppost.sfb directly in the assets folder. This is how we would load that. You can define a directory hierarchy however you please and just reference the path all the way from the assets folder to your SFB right here. So there's a lot more to learn about Sceneform and about how to actually display these in your app. When I was doing my speed run, I used the sample, and so that's a great way to just try this out and see how your assets will look. But if you'd like to learn more about how to do more things with these assets and how to display them in the runtime, you should check out this session. It was yesterday, rendering for Android AR apps, and it's available on YouTube, of course. You can learn a lot more there. So I'm going to jump right into our actual app we built, and let's take it for a spin, see what it looks like now that we've tweaked the parameters in the SFA. All right, so there is our lamppost. It's lit nicely. It's got everything that you would expect of a giant lamppost in the middle of your office. And And it's looking great. That's just what I was going for. So let's jump back to the slides now. And so I want to talk about one other thing, which is I'm asking you to install this Android Studio plugin. You might wonder, what is this plugin going to do to my project build? Do I want to install this? And so let me tell you a little bit about what's going on under the hood. So we've built a Sceneform Gradle plugin. And this is what is actually doing the asset builds that I showed you. When you import, what we're going to do is we're going to add the Sceneform Gradle plugin to your Gradle build. The first thing we do is we just add the class path dependencies to your project build file. You'll note that we load this from the Google Maven repository, so you want to make sure that that's in your project build file. Of course, this is the default for all new Android apps, so this shouldn't be a problem. And then in your app build.gradle file, we apply the plugin just once. We won't do that more than once. But then for every asset that you import, you'll see one of these asset definitions in your Gradle file. Now, you'll see there are a few paths there, and if you remember the import flow, you'll remember that those look very familiar. And in fact, you're right, those are the exact same paths that we had in the import wizard. This is all the import wizard does. It writes these files into Gradle. So could you edit these Gradle files manually if you wanted? Sure, that would be fine. Now, we think that the Android Studio plugin is the quickest and easiest way to get these in, but of course, they can be edited and changed here as well. And finally, once you build and you've got these asset rules in your project, you'll see that here I'm building an APK using the assemble debug rule in Gradle. And what you see is we're getting this compile asset task. And we have a compile asset task for each of the assets that we've added to our Gradle build. And these are added to the dependency chain so that they'll run before the tasks that merge in assets or resources into your APK. And so you can always be sure that these bundles will be updated or these optimized binaries will be updated and ready to go every time you build an APK, and you'll always get the latest and greatest version of the optimized binary that has all your updated parameters, and yes. Oh, sorry, yeah, I forgot about source control. So one thing you might ask, since we're building these files as part of Gradle, do we need to check them into source control? Where should they live? And the truth is, you don't have to check in the optimized runtime bundles. These could just be built as part of your Gradle build. But we would actually highly recommend that you do check them in. Since these are tracked in Gradle and we understand all of the dependencies and the input files that were used to generate our optimized binary, we can always understand when it needs to be rebuilt. And so if you just check in your SFBs, check in your SFAs, and then pull down the latest source from your source control and build, we'll know which we have to rebuild and which we can leave unchanged. And so you'll always have the latest stuff to run. OK, so now we have our basic app. And I'm going to turn it over to Tom, and he's going to tell us how, after we've built an app, we would test it, iterate, and launch that app. So here you go, Tom.
Cool. Thanks, Tim. Hi, everyone. I'm Tom. I'm engineering manager on the AR and VR team. I'm going to talk about some of the tools that we've built to make iterating and building and debugging your AR apps even easier. So first of all, earlier this year, we released ARCore support to the Android emulator. So no matter where you are, what devices you've got, you're always able to build for ARCore. So if you'd like to develop your ARCore app without having to deploy to your device, get up and walk around your room, place your objects, then you can do that. If you would like to develop in a coffee shop or on a bus or on the plane, then we've got you covered. The virtual environment that we let you walk around in, it's got multiple rooms, it's got tables, it's got chairs, and if you also want to see what it looks like with a cat in your room, then you can do that too. So to get started, all you need to do is use Android Studio 3.1 or above, use the latest Android Oreo system image, Make sure you use an image that has access to the Play Store so that you can download ARCore, or there are instructions on our website to sideload it if you'd like. And then it should be the default option, but make sure in the advanced settings that you're using the virtual scene as your camera for the back-facing camera. Once you've settled that up, it's good to go. So walking around your room, it's not as easy as holding your phone up and looking around, but if you've played a lot of video games like me, then you'll find it really, really natural. So you use WASD on your keyboard and the mouse or a trackpad, and you can navigate like a first-person video game. So the really cool thing about the emulator support is we actually run the entire ARCore tracking stack. We don't fake anything. On that rendered image, we just run the full tracking stack, which is really cool because as new features for ARCore come online, then it will just work magically within the emulator. So this week in the keynote, we announced support for augmented images. And whilst all that stuff works, we don't actually have any images in that environment just now. But if you get the Canary build of Android Studio with the emulator right now, then we've added this extra UI, which lets you place an image in your world. You can change the size of it. You can put it on horizontal surfaces, vertical surfaces. And as you can see, we didn't have to do anything to make it work. Augmented images just works perfectly in the emulator. So that helps you iterate. One thing that we've worked really hard on is helping you debug your application. So I want to show you a tool that we've been working on that helps building and debugging these complex immersive scenes really easy. With Sceneform and Unity and Unreal Engine integrations, we've made building your app really easy, but sometimes you want to go under the hood and see what's happening. So we built GAPID, which is the Graphics API Debugger. So it's a really powerful tool that we've been working on that lets you inspect all of the graphics API commands that your application is calling and lets you replay them later on. So if you want to see exactly how your frame is being built, draw call by draw call, or see what resources your app is being used, or investigate like why your app doesn't look quite as you expect, then GAPID can help. So, and it also helps you understand exactly what your GPU is being asked to do as well. So here's a really, really quick example of GAPID. We're just stepping through draw call by draw call. You can see the Andy model, the raw resources that this is using. And you can see every single GL draw elements call, which contributes to your final image. And you can see it built up draw call by draw call. So we're going to go for a quick whirlwind tour through GAPID. There are two main stages. The first stage is tracing, which is capturing every single API call that your app is making. And then secondly, there's replay, which is on your desktop or laptop so that you can step through and reproduce those issues that your app has. So first of all, to get going, you need to capture a trace of your application. So file, capture trace. You have to choose your device, choose your package, making sure your package is debuggable, and then click OK, and then it will connect to your device, start your package, and then it will start streaming this information back. So once you've captured an interesting part of your scene, this is the UI that you get. And you can replay each frame within GAPID and step through it draw call by draw call. For OpenGLES applications, which most of our ARCore applications are right now, we actually capture from the start of the application all the way through until you click stop. Use the film strip UI at the top to choose between the frame that you'd like to take a deeper look at. And then once you've found an interesting frame, you can really dig into the details. On the left, we've got the command view. So this shows every single command that contributed to drawing your frame. It's neatly separated by frame and by draw call. And any of the parameters to those functions can be changed, and you can replay it just to see how that might make a difference. In the center, we've got our frame buffer pane. So that shows what the application looks to up to the current command. In that way, you can step through every single command. We've added a bunch of options so you can visualize that frame buffer in a different way too. So you can edit the histogram. So if your application is particularly dark, you can bring it more into the light, and you can change those parameters. And on the right, there are various tabs for your resources. So you can see the textures that contributed to your application. You can see every mesh. Go and investigate the polygon count. You can see it actually gives the number of vertices and triangles. So you can take a look there. If you also want to, all the shaders that go into building your scene and the raw OpenGL state, you can go and look at that too. So let's take a look at a concrete issue, the kind of thing you might see within GAPID. So this is an example that I created from our Seattle office. This is just an Andy hanging out on a big chess set. It looks like just one or two androids just hanging out there. But a really common issue on mobile applications is overdraw. So overdraw is when you shade a pixel multiple times, that become a performance bottleneck on our kind of bandwidth-limited mobile devices. So you generally want to shade your pixels only 1, 2, or 3 times. So how many times do we think those pixels of that front Android actually get rendered? Well, it's kind of 1, 2, 3, 4, 5, 6, 7, keeps going. It actually goes all the way to 20. And that's really, really expensive on our mobile GPUs. So GAPID can let you see and check your assumptions on how your frame is actually being built up. And just lets you kind of go under the hood and see exactly with Sceneform and with Unity and Unreal, exactly what they're doing. So to optimize that, you could render your objects front to back instead of back to front. So my ask of you all who are building AR applications here is go and take GAPID for a spin. Go and download a trace of your application, go under the hood, poke around, and see. Just check your assumptions. I'm always surprised every time I go and take a capture. So there are a load more features within GAPID. Go and take a look at the github.io link. And we have a lot of tutorials and guides on there on how you can do extra things. GAPID supports Cardboard, Daydream, and vanilla Android apps as well as the Vulkan APIs that are going to become popular over the next few years. So once you've developed your AR app and you've debugged it and it's looking exactly as you want, your next step is to get it out into the world. So we'll talk a little bit about that now. So with AR, there are 2 types of applications that you should think about when you're developing your AR app. There's AR optional and AR required. So your AR optional apps, they can be installed and run on devices that don't support ARCore. But you have to go and test for ARCore support if you want to create an ARCore session. On the other side, AR required means it can't be installed on the device until you actually, unless that device supports ARCore. So for those devices, for AR optional device applications, the onus is on you to go and write that code that checks to see if ARCore is installed and also checks to see if the device is ARCore compatible. So we'll go through an example of what that code looks like right now. So we have a very simple availability API. You go and call check availability, and you wait until that returns true. If your device supports ARCore, then you can go and enable your UI widget that takes you into your AR mode within your session. But before you go and check if you have support, you should check whether ARCore is actually installed or not. So we basically have this simple API that is request install, ARCore APK request install. That can tell you whether it's installed. If it's not installed, it can go and install it in the background for you. Once you've done all that, you can go and create your ARCore session as normal. And so for AR required applications, they're really, really simple. There's really nothing to do. We go and do the whitelisting on the Play Store for you, so it will only be available on devices that have ARCore support. ARCore is auto-installed when the app is installed in these cases. And as new devices are ARCore enabled, these devices will just be whitelisted automatically. So we've, just before we finish up, we would love to get feedback from you on how on this session. But just to recap, we've shown you how to build your AR applications really, really quickly with Sceneform using assets from Poly. We've shown you how to iterate quickly in the Android emulator. Even if you don't have a device, you can go and build ARCore applications right now. We've shown you how to debug gnarly graphical issues in GAPID and understand what your scene is doing. And we've shown you how to ship them on the Play Store. All right, thanks everyone.